So in this video, I'm just going to run through CC10, which is electrolysis. It's a tricky topic, but it's one that I actually feel that we're really strong on, so it's going to be a very short video. Main thing to have a look at is the core practical. We know it's definitely coming up and it has caused some problems in the past, so make sure you know it inside and out. But beyond that, the only thing I wanted to look at was a question something like this. Why does hydrogen, for example, why does hydrogen form at the cathode? And I think I have some model answers in the booklet, but the more recent exam mark schemes required more than what I originally gave you in the booklet, and I just want to make sure we know what we have to write for something like this. So why does hydrogen form at the cathode? Okay, first thing you can talk about is hydrogen ions will be positively charged, so H plus ions will be attracted to the negative cathode. But it's not enough to just talk about the attraction. You need to talk about what happens once the H plus ions actually get to the cathode. You need to talk about the chemical reaction. How are those H plus ions converted into H2? So for that, you can write yourself a half equation. So I've got H plus, and I know I'm trying to form H2. If I've got a positive charge on the hydrogen and I want to get rid of that charge, the positive means it's lost an electron. If I give it an electron back, then it's not going to be positively charged anymore. Because I've got two hydrogens on the right hand side, it's diatomic, I'm forming H2. I need to have two hydrogens on the left hand side, so I've got a big 2 there. And because I've got two hydrogens, they each want to gain one electron, so I need a big 2 in front of the electrons as well. So now I'm talking about the H plus ions going to the cathode because of the attraction, and then this is what actually happens when they get there. This is how H2 is formed. If you don't like your half equations and you'd rather write it in words, you could say that the H plus ions are reduced. Okay, it's always reduction that occurs at the cathode, so tell me that the H plus ions are reduced. The other thing that you could say for example, you were electrolyzing sodium chloride, aqueous. As well as having H plus ions in solution from the AQ, you've also got Na plus ions in solution from the sodium. So why is it the hydrogen ions that get reduced and not the sodium ions? You could say hydrogen is less reactive than sodium, so H plus ions are easier to discharge. And by discharge, I just mean remove the charge. You're starting off with an ion, you're ending up with a neutral molecule, you're discharging the ion. On the most recent mark scheme though, it was this that was really important, the details of the reaction, what happens to the hydrogen. So that you definitely have to include that in your answer, and I include the other 2 points just to make sure you are 100% covered. I'm going to give you another one of these to do, so you can try and do it yourself, answering it in the same format as I have. So instead of looking at hydrogen, what if we looked at chlorine? Okay, why does Cl2 form at the anode? So press pause and have a go at answering that question for yourself. Why does chlorine form at the anode? So as before, I've started off by just saying that my negative chloride ions are going to be attracted to the positive anode. I then need to talk about what happens when they get there. What's going to happen to my Cl minus ions? They're going to be discharged, so I'm going to get rid of that charge. I'm going to form Cl2. The charge minus means that they've gained an electron. To get rid of that charge, they're going to have to lose the electron that they've gained. Again, I've got two chlorines on the right, so I need two chlorines on the left, so I'm going to put a big 2. If I've got two chlorines, they each lose one electron to form Cl2. Again, if you don't like the half equations as much, you could write Cl minus ions are oxidized. Okay, they're losing an electron. Each Cl minus ion loses one electron. Cl minus ions are oxidized, but again, the equation is going to get you that mark. The other thing that you could say, again, let's assume we've got sodium chloride aqueous. as well as having Cl minus ions going to the anode, you're also going to have OH minus ions from the water going to the anode. So again, you could write that Cl minus ions are easier to discharge than OH minus ions. So again, that's why the Cl minus ions get oxidized and the OH minus ions do not. You can say Cl minus ions are easier to discharge. So with any of these questions on electrolysis, don't just talk about the attraction, you have to talk about oxidation and reduction, ideally using half equations. If you're not comfortable with half equations, explain it in words, but you have to talk about the reactions that are taking place at the electrodes. The only other thing that kind of springs to mind as kind of an area of concern, other than the core practical itself, is there's a question that came up in one of your exams about ionic compounds conducting electricity, acting as electrolytes. And I can't remember what the exact question was, but it was something like you had two ionic compounds. So you had calcium carbonate and let's say you've got sodium hydroxide. So I've got two ionic compounds, and it says you mixed both of them with water, and this one was an electrolyte and this one wasn't, and they asked you to explain. So if they're telling you it's an electrolyte, that means it does conduct electricity. So when you took sodium hydroxide and you mixed it with water, it was able to conduct electricity. And that's what we'd expect, okay? Because when you take an ionic compound and you dissolve it in water, you then end up with ions that can move freely. And because they can move freely, they can carry the current. So you'd expect it to conduct electricity. But then over here, I've also got an ionic compound, and they're saying that even when you mix it with water, it's not conducting electricity. If it dissolved in water, it would be able to conduct, those ions would be able to move freely. So the fact that they're saying it's not an electrolyte, that must mean that it doesn't dissolve in water at all. Okay, your calcium carbonate stays solid. When you add it to water, because it's solid, the ions cannot move freely and it cannot conduct electricity, therefore it's not an electrolyte. They could also ask you, well, what could you do to calcium carbonate? If it's not dissolving in water, what else could you do to get it into kind of liquid form? And the answer there would be you would melt it. If you melt it, the ions will be able to move freely, and then it will be able to conduct electricity. The problem there, though, ionic compounds, very high melting points due to the strong electrostatic force of attraction between oppositely charged ions. It would require quite a lot of energy to melt the calcium carbonate. That is essentially it from electrolysis, but please make sure you go over your core practical. It is a potential 6-mark question. So look over the core practical booklet and make sure you're comfortable answering questions on the practical.